eigenvalue and eigenvector. A be an n-cross-n matrix and non-zero vector K is called the eigenvector if there exists a arbitrary constant lambda such that AK equal to lambda K, and K is called eigenvalue. So here AK, A is an n cross n matrix, K is a column matrix, n cross n one matrix, so AK is possible. AK is a matrix multiplication that is possible. Similarly, lambda is scalar and K is a matrix, so lambda K is also possible. So here we said AK equal to lambda K. So we got this equation. Next we need to find what is K. That K is eigenvector and corresponding scalar is called eigenvalue. So we already said A matrix A, n cross n matrix A, and K be a column matrix. So AK equal to lambda K. This equation satisfied K. Solution K is called eigenvector and corresponding arbitrary term is called eigenvalue. So I would like to write AK minus lambda K equal to 0. So we can subtract matrix. Therefore, I would like to write AK minus lambda K equal to 0. So here K are same. So A minus lambda into K equal to 0. So here lambda can be written as matrix form. So A minus lambda I into K equal to 0. So A is a matrix, lambda I is another matrix, A minus lambda I is a matrix. So this matrix B, I will say B, BK equal to 0. So first of all we need to find the solution of this equation. A minus lambda I into K equal to 0. That solution is called eigenvector. Okay. So generally I can say A is a matrix A11, A12, etc. A1n, A21. In this section I will explain how to find eigenvalue and eigenvector. What is the algorithm to find eigenvalue and eigenvector? So first of all, given a matrix A or system of equations, we will form coefficient matrix and variable matrix and constant matrix. Then we take coefficient matrix, and first of all you find out the characteristic matrix. Characteristic matrix is formed by A minus lambda I. Then you find out the determinant of characteristic matrix and equate to 0. We got characteristic equation. Then that equation, solved that equation, we got the roots of characteristic equation. Roots of characteristic equation is called eigenvalue. Roots of characteristic equation called eigenvalue. And each of the eigenvalue we will form A minus lambda. Lambda 1 be the eigenvalue. We can form A minus lambda 1 I and x equal to 0. Then this solved this equation. We got the x values. This x value is called the eigenvector. Okay. Then I will explain one problem. Find the eigenvalue of 1, 2, 1, 6, minus 1, 0, minus 1, minus 2, minus 1. So our A is 1, 2, 1, 6, minus 1, 0, minus 1, minus 2, minus 1. So first of all, you find out the characteristic matrix A minus lambda I. So 1, 2, 1, 6, minus 1, 0, minus 1, minus 2, minus 1, minus lambda 0, 0, 0, lambda 0, 0, 0, lambda. So we got 1 minus lambda, 2, 1, 6 minus 1 minus lambda, 0, minus 1, minus 2, minus 1, minus lambda. So this is the matrix. Then you find out the determinant. Determinant of A minus lambda I equal to determinant of 1 minus lambda, 2, 1, 6 minus 1 minus lambda, 0, minus 1, minus 2, minus 1, minus lambda. So 1 minus lambda into minus 1 minus lambda minus 1 minus lambda into minus 2 into 0, 0, minus 2 into 6 minus 1 minus lambda 0 plus minus 12 minus 1 into minus 1 minus lambda. So you can write down for one more. I will write 1 minus lambda into in the similar manner. How to find the determinant? At the similar manner, we will find out the determinant in this matrix. Determinant in this matrix. So 1 minus lambda into minus 1 minus lambda square minus 2 into minus 6 1 plus lambda plus 12 minus plus 12 minus 1 plus lambda. Plus lambda. Then expand. We got 1 minus lambda, 1 minus plus 2 lambda plus lambda square minus 12 plus 12 lambda plus 12 minus 1 minus lambda. That is equal to 1 plus 2 lambda plus lambda square minus, we will expand in this form. We will get minus lambda minus 2 lambda square minus lambda cube plus 12 lambda square, 12 lambda plus 12 minus 1 minus lambda. That is equal to lambda cube minus lambda cube lambda square minus 2 lambda square minus lambda square 2 lambda minus lambda lambda plus lambda. Okay, minus lambda minus 2 lambda cancelled. So we got 12 lambda. One minus 1, 12 minus 12, 0. So we got minus lambda cube minus lambda square plus 12 lambda equal to 0. Then you can take lambda outside, minus lambda square minus lambda plus 12 equal to 0. So we get lambda. We can solve this quadratic equation. We got lambda plus 1, lambda minus 3 equal to 0. So lambda equal to 0, minus 4 and 3. So eigenvalues are 0, minus 4 and 3. Eigenvalue and eigenvector 5 minus 2 minus 2, 2. So determinant A minus lambda I equal to, so I equal to 0. First 3 steps I took one step. So we can write down 5 minus lambda. Corners are only change. No others are not change. So we can write down 5 minus lambda, minus 2 itself, minus 2 itself, and 2 minus lambda. This is the characteristic matrix. Its determinant equal to 0. So then we find out the determinant. 5 minus lambda into 2 minus lambda minus 4 equal to 0. Then you multiplied 10 minus 5 lambda minus 2 lambda plus lambda square minus 4 equal to 0. So lambda square minus 7 lambda plus 6 equal to 0. So you can take the factorization method. You got multiplied two number roots. We got plus 6 and adding minus 7. So lambda minus 1 into lambda minus 6 equal to 0. So lambda equal to 1 and 6. So eigenvalues of this matrix is 1 and 6. Next we need to find corresponding to eigenvalue lambda 1 equal to 1 and lambda 2 equal to 6. Corresponding to these eigenvalues, we need to find the eigenvectors. So first we take lambda 1 equal to 1. So you can write down y minus 1, minus 2, minus 2, 2 minus 1. So our matrix is 4, minus 2, minus 2, 1. Corresponding to lambda equal to 1, our matrix will become lambda minus 2, minus 2, 1. And we can write down the variables x1, x2 equal to 0. Next we need to find x1 and x2. That is an eigenvector corresponding to lambda 1 equal to 1. So 4x1 minus 2x2 equal to 0, minus 2x1 plus x2 equal to 0. Second equation we can write down 2x1 minus x2 equal to 0. And we multiply by 2, we got 4x1 minus 2x2 equal to 0. So first and second equations are equivalent. So we have only one equation, 4x1 minus 2x2 equal to 0. So we have one equation and two unknowns. So we need to take arbitrary constants. 2 minus 1. Two variables and one equations. Number of variables are 2 and number of equations are 1. So 2 minus 1. Number of parameters are 1. Let x1 equal to or x2 equal to a. We can take x1 or x2 in a parameter. So I would like to take x2 equal to a. 4x1 equal to 2x2. 2x1 equal to x2. So a equal to 2x1. So x1 equal to a by 2. So we got a by 2 and a. This is the solution of this equation. A by 2 a. So our eigenvector we can take a equal to 1. x1 equal to 1 by 2. So our eigenvector is 1 and 1 by 2 and 1. Otherwise we can take here 2. A equal to 2 and x1 equal to 1. 1 and So a lot of eigenvectors we will get, but linearly independent eigenvector is only one linearly independent eigenvectors. So corresponding to lambda, we will take only one solution. So we can take this or other any solution of this equation is an eigenvector. But linearly independent eigenvector is only one, corresponding to lambda equal to 1. Similarly, we need to find lambda equal to 6. Lambda equal to 6, we got 5 minus 6 minus 2 minus 2, 2 minus 6. So minus 1 minus 2 minus 2 minus 4. So minus 1 minus 2 minus 2 minus 4. x1 x2 equal to 0. So we got minus x1 minus 2x2 equal to 0. Second equation is minus 2x1 minus 4x2 equal to 0. In this equation we multiply by 2. We got second equation. So these equations are equivalent. So we only take one equation. Minus x1 minus 2x2 equal to 0. So we can write down minus x1 equal to 2x2, x1 equal to minus 2x2. So I would like to take here one equation and two unknown. So we have 2 minus 1 parameters. That means one parameter. I would like to take x2 equal to a. So x1 equal to minus 2a. So a and minus 2a be the solution of given equations. So our eigenvalues are, I will give a equal to 1, we get 1 minus 2. This is the eigenvector corresponding to lambda equal to 6. So we got lambda equal to 6, we got minus 2 and 1 eigenvector. Lambda equal to 1, we got 1 and 2 eigenvector. So these are the corresponding lambdas and corresponding eigenvalues.